Hello, my name is Tom Gregory and I'm a product manager here at Future Facilities. Today I'll be talking about why you should switch to our film and simulation software 6SigmaET. 6SigmaET is a film and simulation tool designed specifically for the electronics industry, and we've designed a fully functional film and simulation software that solves conduction, convection and radiation, and can solve thermal simulations of a wide range of products across the electronics industry. So these are just a few examples of the products that have been simulated in 6SigmaET, from LEDs to servers to consumer electronics, right down to detailed component modelling, right up to large cabinet scale models. And you can see we utilise detailed CAD geometry as well as building up models out of our modelling objects as well. So this is just a flavour of some of the devices that have been simulated in 6SigmaET. Last year we celebrated the 10th anniversary of 6SigmaET here at Future Facilities. Over the last 10 years, many companies have switched to 6SigmaET, and this is just a flavour of those companies. So, big engineering companies like Bosch, defence companies like Celex, Roder and Schwartz, who do a lot of test equipment, and household names like Facebook and Motorola and Qualcomm doing the chip design in 6SigmaET. Today I'll be talking about why these companies and more have decided to switch to 6SigmaET, and the benefits to the company and to engineers to switching to 6SigmaET. So these are the topics that I'm going to talk about today. So film simulation doesn't need to be slow. We'll talk a little bit more about that, how 6SigmaET can be used throughout the design process, how we can do really detailed film simulation, how we check that 6SigmaET is accurate so you get results that you can rely on, how easy it is to use 6SigmaET, and importantly, if you decided you'd like to switch and try 6SigmaET, how to switch from another product to 6SigmaET. So first of all, why did we decide to develop 6SigmaET? Well, we do a lot of research in the industry and we were quite surprised by this statistic. So 40% of electronic engineers consider film simulation to be either too complex or too time consuming. So we really want to work on trying to solve that problem really. And simulation doesn't have to be slow, but we found through research that many film and simulation engineers are unhappy with the traditional simulation packages that they've used, and one of the main reasons for that is the slow speed. So we found that 30% of film engineers spend over a day building their simulation models. 41% say they'll typically spend over an hour just gridding, so you're not really doing any engineering there. You're just preparing for simulation, and that could take over an hour. And 66% of film engineers say they have to spend a day or more solving their simulation. So how does 6SigmaET solve that? Well, one organisation that struggled with slow speeds was Roder and Schwartz, who primarily make test equipment. I'm going to talk you through their evaluation of 6SigmaET and how it has affected their process. So Roder and Schwartz did a big comparison study of 6SigmaET and another major simulation software in the electronics industry, and they found that 6 Sigma ET was faster every single stage in the process, from CAD import, gridding, solving and analysis. And they've been doing very detailed thermal simulations, as you can see in the picture. So CAD import preparation went from days to just a few hours. Gridding went from days to a matter of hours. You can see solving again went from days to just a few hours. And overall, in this particular example and many other examples that Rohde & Schwarz did, the time to do one project went down from weeks to just a couple of days. And these are some of the products, the type of products that Rohde & Schwarz simulated, from handheld oscilloscopes to very powerful on-bench equipment. And they actually did 12 models in 6 Sigma ET in their evaluation and compared it to competitive software. The competitive software failed to solve 7 of the 12 models, and the remaining 5 were solved with low detail. 6 Sigma ET managed to solve all 12 models in high detail. So as well as the speed, it's not compromising the level of detail in the model. We can solve very highly detailed models in just a few hours. And I would encourage you, if you want to learn more about this, we've got a more detailed document on our website which discusses in detail those 12 models and the rest of the requirements that Rohde & Schwarz had for their thermal simulation tool. So Raymond's one of the engineers who works at Rohde & Schwarz, and this is what he said about what Rohde & Schwarz need out of a thermal simulation tool. So thermal simulation tools have to be accurate and should reduce the time of setting up the thermal model. Speed and accuracy are mandatory. Nevertheless, the tools also have to be user-friendly, stable, and have to have very good support. So I'll talk a little bit more about accuracy later. But the speed and accuracy are, as Rem said, absolutely important for your thermal simulation tool. Another company that switched to 6 Sigma ET is a company called Tentec, who are a military and aerospace engineering firm. They do a lot of work in the aerospace industry, and including a lot of work with liquid cooling. And like Rohde & Schwarz, who had massive efficiency gains by switching to 6 Sigma ET, Tentec also had drops of up to 30% as well. So huge time savings, and what William Villiers said, who's with the Director of Engineering at Tentec, is that 6 Sigma ET's high performance cloud-based solving allows us to scale without hardware limitations, gives you the opportunity to double the number of projects we take on. So having a real impact on his business, being able to double the number of projects that we can take on. So now I want to show you a video that William Villiers did that talks about a little bit more about why he chose 6 Sigma ET to be used at Tentec in their thermal simulations of electronics.
ET does what we want in a manner that a thermal engineer or somebody who designs electronics would want things to be presented or things to be represented. So that's one of the things that that attracted us in a specialized software as opposed to kind of a generic, hey, here's the CFD, you can do all this stuff. But this product is very specialized and has some really good features that make us more responsive. And we've been in the last projects that we have where we have no time to actually deliver, practically no time, we were able to catch up and actually deliver in time, which I know for a fact that with the previous tools we had, we would have struggled quite a bit. The first one is the way ET models components and models boards. So it takes that system approach, which is we start with a very basic shape and we can refine it as much as we want. So you can say, okay, this component is a little cube. And slowly you say, well, actually, this component is a BGA. It's got X number of balls. And now we want to model this, this, and that. So you can go as deep as you want, or you can stay at a fairly high level, which helps us. We start at a fairly high level naturally in conceptual design or RFP type of work, up to, or I guess down to the little greedy detail of what's the temperature on this particular solder ball, and those things. And similarly for the board modeling, can be just a simple average coefficient, or we can go all the way to looking at traces and all this. This is one. The second one, which I didn't anticipate initially when we looked at the software, was all the liquid cooling abilities that are in the software that are, to my knowledge, fairly unique to ET and absolutely indispensable for us. And I didn't know that until we got a certain number of projects, and it looks like all the projects that we're getting now involve liquid cooling. So turns out we made the right decision by getting ET. And thirdly, because we are not necessarily the biggest company in the world, we have a limited budget as far as hardware, and the fact that ET can scale up to a cloud-based HPC server like Rescale and does that very well, that helps us build better, bigger models. And I don't necessarily want to have all this cluster in-house, and certainly not the IT department to support it. And so being able to ship that to Rescale and have ET perform very, very well on those clusters is a very good tool for us. You really want a specialized tool that actually focuses on modeling the proper things properly. And I think ET is that kind of tool where, a component is a component. It's not just a cube with thermal, properties. A board is a board. So it recognizes all those things, recognizes the interaction, and is able to connect things together in a manner that makes sense, and that speaks the language of the thermal engineer or thermal designer, really. That good understanding of electronics works very well with this software, and it's clear that the product development team actually does that for a living, electronics cooling, and it's obvious. It's not just software engineers putting features in. It's actually they're putting features that that we want.
So one of the things that William Villa mentioned in his video is that they do thermal simulations across the design process and do it from an early stage with little detail, and then as they go through a project they then increase the level of detail. And it's just wanted to note that Six Sigma ET can model at all stages of the design process, from concept in parallel when you're doing some early designs, the implementation of the design, right through to when you've got the final designs and it's all been finalized and you've got the final CAD and you're just doing a final check. Obviously the earlier you can identify a problem, the easier it is to fix it, really. So to do this, we can do the concept modeling and the early stage implementation modeling using objects in 6SigmaET, our intelligent modeling objects, and the final design we can do by import, and I'll talk you through that a little bit in more detail. So this model here on the right hand side is a 6SigmaET model of a server, and it's been built entirely using the intelligent modeling objects in 6SigmaET. We have 120 of these different types of these modeling objects, which are all basically parts you'd find in a electronic system, and we're constantly gathering feedback from the market about what modeling objects you'd like to see in 6SigmaET and adding new objects and updating objects every single release. These objects can be easily parametrically defined based on data you've got, perhaps from data sheets, and importantly, because we're designing for the electronics industry, these can be intelligently placed and intelligently moved around, as you can see in the graphics on the bottom of the screen. So really easy to create a 6SigmaET model, even if you haven't got the CAD designs and the PCB designs. But if you have got the final CAD and PCB designs, you can really easily import them into 6SigmaET. So we can import from all the major CAD tools, SolidWorks, CATIA, Autodesk, etc., through industry standard file formats, bringing in the full detailed CAD You don't need to go through a preparation step, you just import them directly into 6SigmaET, and 6SigmaET can work with that CAD directly. And same with ECAD, we support all major ECAD tools from Cadence, Mental Graphics, Zuka and Altium, etc., and through a wide range of file formats we can import them through into ECAD. AW++ and IPC 2581 are relatively new to 6SigmaET, but these are really powerful formats, and we can import the full data of the PCB, all the copper trace, all the thermal wires into the software, and there's an example of a detailed PCB there. But there's no point importing all that data into the software if the software can't handle that data and use it effectively, if it can't cope with the complexity. But 6SigmaET has been designed from the ground up to cope with the complexity of modern electronics. So we can solve up to 750 million grid cells. Often other tools, sort of at 1 to 2 million, is typical of the maximum, but we can really go up to a very large number of grid cells. Having said that, we have unstructured gridding technology, which places only the amount of grid cells that are necessary. So for many models, it'll be significantly less than that. We only place grid cells where necessary using our intelligent gridding. We can solve models really fast. So this is said at the start of the presentation. So with the right hardware and with our partner Rescale for cloud computing, we can solve a 100 million grid cell model in an hour. Many other tools would take literally days. We can handle tens of thousands of objects, so multiple PCBs with hundreds of components are not a problem at all, and can also cope with complex CAD and PCB designs, as you can see on the pictures on the right hand side. So this enables us to get really accurate thermal models with high levels of resolution. And as everyone said, 6SigmaET has to be accurate. These leading electronics companies would not be using 6SigmaET if it wasn't an accurate thermal simulation tool. And we continuously validate against a wide range of analytical solutions and published data, and our customers regularly compare 6SigmaET thermal simulation data against measured data as well. As an example on the left from Thales of some PCBs and components on PCBs, and then UTA, University of Texas at Arlington, did a study of the open compute servers and again found excellent match between the CFD study and experimental. These are both on our website, so if you want more details, please look on there. But also get in touch if you want our full validation document as well, so we can send that over as well, which has all the dozens of validation documents that the validation cases that we validate against. The other thing I wanted to point out is the 6SigmaET is really easy to use. One of the main reasons for this is that we, from the start, are designed for engineers in the electronics industry. So everything we do is focused on making sure it's easy for people modelling electronics. So that comes through everything from how our objects work, through to the gridding, through to how the results are analysed, so throughout the process. We have a modern sort of single window user interface, utilising ribbons, a nice big 3D graphical display in the centre. Gridding can be one of the most challenging things in the CFD simulation, but in 6SigmaET it's basically automated, although if you want the power to change the grid, then we've got the tools to do that as well, and automated reporting as well. And again, I just wanted to go to what our customers are actually saying about how easy 6SigmaET is to use. So Martin Pace at Motorola said the suite of features is user-friendly, easy to use, and provides good resolution and accuracy in modelling. So yeah, it's really important to note that just because we're easy to use doesn't mean that we're a tool that produces simple or simple answers or not the full level of detail. We're both easy to use, but also provide a lot of detail and also really accurate models. ATS doing their heat sinks, excellent correlation, and as said, it's really easy to create the CFD model. So Celex easily built up the model from CAD and PCB data, and found it really fast to do models. And Michael Schroeder at Intel said overall Six Sigma ET is an excellent platform that has improved on a lot of features that have been deficient in terms of usability of the legacy platform. So he said compared to the other tools on the market, they've been around a little bit longer. Six Sigma ET is a lot more easy to use. But there is challenges with switching. So the vast majority of thermal engineers are not completely satisfied with their current simulation package, but mainly just haven't switched providers in over 3 years. And we understand that it is a challenge to switch tools. You got very used to the software, learns all the tips and tricks, built up a library of parts, and if you become very familiar with the tool. That is why we've really focused on making it as easy as possible to switch from another thermal simulation tool. So the first thing I want to say is give us a try. We offer a free 30-day trial of Six Sigma ET. This is fully supported, so we partnered with one of our engineering team who will guide you through the process of creating a model in Six Sigma ET, and you can see how quick and easy it is to build a model and see if we can get accurate results. So really recommend do that trial and see how it can benefit your business and your team. But if you do then sort of decide you want to switch, I'm sure you have questions about how you transition from another tool on the market to Six Sigma ET. And one thing we and other people in the industry have been working on hard over the last couple of years is making it possible to transfer data from the major tools on the market, IcePack and Flowtherm, get the thermal models, export into an open format called ECXML, and then import that into Six Sigma ET. So if you've got some libraries that you've got in Flowtherm and IcePack, you can bring them into Six Sigma ET and use them as part of your Six Sigma ET model. As I said, we are working with really big players in the market to improve data exchange between thermal simulation tools. So Intel, so they can exchange their chip data across the entire market. Mental Graphics, obviously maker of Flowtherm, Ansys, who make IcePack, Qualcomm, another chip manufacturer, and JEDEC, which is a standards body. So there's a committee there working hard to improve the format and make it even easier to transfer data between tools. Six Sigma is said to support ECXML file format, which exchange full thermal models between different thermal simulation tools. And we also support the Delphi model, which is a way of sharing Delphi compact models, which are used for primarily semiconductor components. And as I've mentioned earlier in the presentation, we support a wide range of industry standard formats for exchanging CAD and PCB data as well. So in this webinar, I've given you sort of a high-level overview of the benefits of switching to Six Sigma ET and some of the functionality. This is a webinar series, and we've got 2 more webinars coming up. One on liquid cooling and one on modelling a VR headset. But don't worry if you're not building a liquid cooled system or not modelling a VR headset. These webinars are really focused on going into a little bit deeper and being able to see how to build a model in 6SigmaET. So we go into a lot of detail about the steps involved in creating a model in 6SigmaET. So it'd be great if you can join us in one of these webinars. So this concludes my webinar. So I'll pause for now, and I'm really interested to hear any questions that you might have.